grey mass that you can see there to the right of the launcher is the KZM, it's called. Inside it are all the feed lines, the umbilical lines connecting the vehicle and the upper stage, the satellites, to the teams on the ground. And those are being disconnected right now. This is the scheduled time. And a word about the ignition sequence. We throttle up the engines gradually. We switch the engines on 16 seconds before liftoff. We throttle them up gradually so that we can check that the engines are working correctly before pushing them to full thrust, which is, of course, when Soyuz leaves the pad. And when that happens, you'll see those 4 arms below. Can you see the blue arms? Can you see the yellow at the bottom of them? That yellow is a counterweight. Right now, the vehicle is suspended on those 4 arms. It's called a tulip. And at launch, they rotate away. Getting closer to the 1-minute mark, the range operations manager will call that out.
À tous les DDO, attention pour moins 1 minute. Top, à 0 moins 1 minute.
We are 1 minute to launch. We are orbiting the 4th batch of satellites in the O3b constellation, which Thales Arianespace built for SES networks. And we're flying on board the 18th Soyuz to launch from the Guyana Space Center. Our best wishes now to all the teams as we watch the launch.
Largage du mât KZM. À tous de DDO, attention pour la séquence finale lanceur. Top, H0 moins 20 secondes. Largage du mât VKM. Allumage du pilotage. Attention. Top, 9, 8, 7, 6, 5, 4, 3, 2, 1. Top, décollage. Du lanceur. Les moteurs des premier et deuxième étage fonctionnent normalement. Bonne stabilisation du lanceur. Le vol est nominal.
Beautiful pictures there in the clear blue sky above the Guyana Space Center, over the Amazon rainforest. Soyuz blazing a trail. Range Operations Manager is telling us that everything is going according to plan, everything's nominal.
La propulsion du premier et deuxième étage est nominale.
The propulsion of the first stage is nominal. Our altitude, bottom left, 36 kilometers above Earth. Our speed coming up to 2 kilometers per second. And you can see the boosters being jettisoned. See how they twist and turn. All part of the plan. We have confirmation there of separation, and we saw them. We don't need them anymore. The boosters can fall away. We're shedding weight. We're burning the core stage now. The Block A burns for nearly 5 minutes. Picking up in speed there on the right-hand side and climbing into space. Right now we are 78 kilometers high and getting closer to what we call the Kármán line. That's the border with space. It's named after the Hungarian-American aerospace engineer Theodor von Kármán, who died in 1963. And it's where the air becomes so thin that we can no longer support vehicles with wings, and we have to use rocket science to stay up. Look at the front of the vehicle there. That's the fairing, the nose, and in there are the satellites. It's protecting them from the rigors of the launch. Notably the acoustic vibrations. You can just imagine how loud it is. Everything's going according to plan. And also friction, because as we fly through the dense part of the atmosphere, it causes the outside of the fairing to heat up. But as we get closer to the Kármán line, the air becomes so thin that we hardly have any friction and we don't need the fairing anymore. So this is the scheduled moment where we lose it. It gets jettisoned and we can see our satellites for the first time. Attached there on the front, and he's confirmed that the fairing has been jettisoned. Attached there at the front, the left-hand side, some great images there from cameras on board a previous launch.
Le fonctionnement du moteur du bloc A est nominal.
He's telling us that the functioning of the Block A motor is going normally. So the 4 O3b spacecraft, lovingly built by the men and women at Arianespace, who are experts at this kind of thing. And if you look in the middle of the rocket, you can see a sort of latticework structure by the orange section. That is because Soyuz uses what's called a hot stage technique when it separates the stages, the second and third stage. The third stage engine switches on before the second stage switches off, and he's confirmed there that separation. So you can see our tracking stations here. Galileo, that's at the Guiana Space Center. And then Natal, that's on the northeastern coast of Brazil. Then we have Ascension in the middle of the Atlantic. And we're heading across the Atlantic. It takes a little bit of time for information to get from the launcher to us here at the CSG. Those stations send the information back here, but it has to go via Moscow first in order to be validated.